All right, so we're gonna graph, which is exciting. Hence why you have a ruler. We're gonna graph straight lines again. But there's something a little bit extra we have to do, because if you remember, we were graphing things that look like y equals 2x minus 1. And you'll notice that that problem says y is greater than or equal to 2x minus 1. So we got the equal to part, which is the line, but we have to graph the greater than part. So I'm gonna show you how to do that. But before we do, I want you to look at those 6 different coordinates. So 0, 5, -1, -1, 1, 1, 3, 0, 4, 3, and -1, -3. So we want to see, of those 6 points, which ones are going to give me a true statement. What I mean is, if I substitute 0 for x and 5 for y, does it give me something true? So let's do that. We're going to put in 0 for x and 5 for y. So 5 is greater than or equal to 2 times 0 minus 1. Is that true? It is, because if we simplify the right-hand side, 5 is greater than or equal to -1. So let's underline that first point. 0, 5 does work. Let's try -1, -1. So -1 is greater than or equal to 2 times -1 minus 1. So what does the right-hand side equal? -3. Is -1 greater than or equal to -3? Yeah, negatives, yeah. Thinking negatives. -1 is greater than or equal to -3. All right, let's try 1, 1. 1 is greater than or equal to 2 times 1 minus 1. What does the right-hand side equal? 1. Is 1 greater than or equal to itself? Yes. So I want you to try those last 3. So underline them if they're true. Don't if they're not. So 3, 0, 4, 3, and -1, -3. And make sure you plug the right number in for x and the right number in for y. When I say right, I mean correct number in for x and the correct number in for y. All right, so for 3, 0, we have 0 is greater than or equal to 2 times 3 minus 1. Well, what's the right-hand side? 2 times 3 is 6. 6 minus 1 is 5. Is 0 greater than 5? Nope, 'tis not. What about 3 is greater than or equal to 2 times 4 minus 1? Nope, it equals 7, so that would not be true. And then the last one, -1 is greater than or equal to 2 times -1 minus 1. Oh, -3, I messed that up, didn't I? Oh my gosh, did she open the door? No. Yay, look at, oh, Annalisa, did you take Miss Werfel hers? Okay, you can lay them out now. Thank you. Was it easier to find this time? I gave you good directions. Okay. Is -3 greater than or equal to 2 times -1 minus 1? It's specifically, it's equal to, right? -3 is equal to itself. So we're going to underline that one. So now we get to graph. Luckily, we graph it the same way we would a line. So if this said y equals 2x minus 1, we would start where? Where would we put our first point? At -1 on our y-axis. So go ahead and put your first point there, just like we've always done. Then what will we do? Up 2 and right 1. Beautiful. Because that slope is the number in front of x. So go ahead and take your ruler, draw your point, put some arrows on both ends of that line, or draw your line through the points. okay, this line is the graph of y equals 2x minus 1. We want to graph y is greater than or equal to 2x minus 1. So we have half of it done. So we got to decide. To get the greater than, we're going to take our highlighter and we are going to highlight 1/2 of this graph, either on the left side of the line or the right side of the line. And the way that we're going to make that decision is we have to see where these points are that worked. Are those points on the left-hand side of this line or the right-hand side of this line? So let's go ahead and plot the points that were true. So let's plot 0, 5. 1, 2, 3, 4, 5. That's on the left-hand side of the line. Where is -1, -1? What side? It's also on the left-hand side. What about 1, 1? One, it's on the line. Yeah, it's an equal to. Okay. And then the last one we circled was -1, -3, which should also be on the line. So we already have on the line covered. We already drew the line. So where should I be highlighting? Where are those points located? Are they located on the left or the right? The points I just drew? Yeah, we know our left from our right, right? On the left. So I want you to take your highlighter and you want to highlight everything that is on the left-hand side of that line. Again, this is not art class. Just scribble some highlights. You don't need to like color in the lines or anything. Just like make it apparent which side you're coloring. So to prove to you why the left-hand side makes sense, let's plot the points that we X'd out. So what was one of the points we said didn't work? 3, 0. And 3, 0 is on which side of the line? The right. That's why I didn't highlight over there, because 3, 0 did not work when I plugged it in. What other number didn't work? 4, 3. Notice how that's also on the right side of the line. That's why I didn't highlight over there, because that point also did not work. Do you need me to clarify at all as far as the shading? I call it shading, so highlighting part. So what's another point that should work? What point is in the shade in the highlighted region? Just pick one. -2, 1. So that means if I substitute 1 for y and -2 for x, it should give me a true statement. Does it? It does. 1 is greater than or equal to -5. What's the easiest point on the entire graph? 0. Is 0, 0 in the shaded part? It is. So let's test that point. 0 is greater than or equal to 2 times 0 minus 1. 0 is greater than or equal to -1. True. So all of the points, any of those that I pick on the shaded part should give me a true statement. Any of the points that are not should give me something that's not true. So that's why I shaded on that side, the left side, right, Thorn? The left side. Yeah. If you don't know your left from your right, go like this. Well, you go like this. And the one that makes an L is the left. Oh. Oh, yeah. L. A capital L, I guess. Okay, so we graphed. The only difference between the equals and the greater than is the shading. So anytime we have an equals, we just draw the line. And then if there's a greater than or equal or a less than or equal, we'd have to shade on one side or the other of the line. Okay, so the senior class is raising money for Grad Bash. Does anybody know what that is? No. Okay, so when you're a senior in high school, like, you know, when life's back to normal, hopefully someday, Universal Islands of Adventure in Orlando. They do like an event. It starts like 10 o'clock at night and goes to like 6 in the morning. And it's just like for seniors in high school to like go. They have like a concert and like you get to ride all the rides and stuff. It's pretty cool. I did it when I was in high school. Yeah. Yeah. It's like a big.
Wait, so you stayed all night?
Yeah. Like you go down there at like after school and then like stayed and then drove back afterwards. Huh? Yeah. No sleep. Yeah. Back, you know, when I was young and could do that. Huh? Oh, yeah. They do it for 8th graders too. But it's not like all night. It's like from 4 to midnight. So like we were supposed to do it last year and then we were supposed to do it this year. But that's not going to happen.
Next year, would it be
So hopefully next year y'all get to go. No, like it'll be like, you know how you do an end of the year field trip? That was the 8th grade, like end of the year field trip. So you can like sign up to go.
I'm signing up.
Yeah, I mean, I've been to DC with school multiple times. We were supposed to go in November, then we moved it to March. And then obviously that's not going to happen. So, huh? Mm-mm. Hopefully next year. But again, we don't know where the world's going to be. So just depends. Regardless, grad bash. So maybe next year it's called grad venture is the 8th grade one, grad venture. The students' parents are donating cakes. The students plan to sell entire cakes for $20 each and slices of cake for $3 each. If they need at least $500, how many of each should they sell? So there's an infinite amount of combinations of cakes and slices you could sell to make more than $500. So what is one possible combination of cakes and slices to make at least $500? Go ahead, Jonathan.
You could do 500 whole cakes and 500 slices.
Okay, 500 cakes and 500 slices. That would give you a whole lot more than $500. What other combination could you use? 200 cakes and 15 slices. If I'm being like ridiculous, I could say 1 million cakes and 1 million slices. Still gonna be more than $500. One slice and 600 whole cakes. Yeah. 1 billion cakes, 1 billion slices. Like it does not matter as long as your total came out to be more than $500. So we're gonna write an inequality. X is gonna be whole cakes. And then Y is going to be slices. So for whole cakes, they cost how much each? 20. So 20X would represent my cost for however many whole cakes I buy, plus slices. How much are slices? 3, so 3Y. And I need at least 500. Greater than or equal to 500. All right, before we draw our graph, your x-axis, which is whole cakes, you need to count by 4s for it to be able to fit. My numbers are very close together. Sorry about that. And then for your y-axis, any suggestion? 20s. 20s makes it work. Yeah, 20s. Is that what it's called? Skip counting?
You just think of like 8 times 1. Well,
Yeah,
4
now
times
it's all
1.
multiplication. There's no.
I mean, in my head, I probably went 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12.
When I just start, I just already like automatically
Skip counting, never heard that. Okay, so to make our graph, we could put this in slope-intercept form, use the y-intercept, use the slope, but unfortunately, our slope and our y-intercept are gonna be fractions, decimals, all that stuff. So there's a different strategy. So if we just sold slices, no whole cakes, how many slices would I need to sell to get exactly $500?
150. No.
You have this thing called a
125.
you have this thing called a calculator.
115.
Oh yeah, I have a calculator, I forgot.
120.
Go for it, Esteban. Okay, what is it? 166.6666666666666.
166.
So yeah, so I can't sell 166.6666666 slices. But if I only sell 166, I didn't make my $500. So I would have to sell 167. Now I know our graph is not gonna be perfect because we counted by 20s, but on our y-axis, we wanted to put a point about where 167 would be. Again, doesn't need to be perfect. Oh, that's not where it would be. Does not need to be perfect, just about 167, I'm gonna say is right there, maybe 20, 40, 60, 80. Yeah. No, that was the hardest one. So then on the flip side, what if I just sell whole cakes? How many would I need to sell to get exactly $500? 25, because they cost $20 each. $500, I would need to sell 25. So on your x-axis, put a point where about where 25 would be, because that's representing just selling whole cakes and no slices. And then use your ruler and just connect those 2 points we made. Why is this graph only in the first quadrant? The graph we made before, we used all 4 quadrants, the whole graph. Why is this graph only in the first one? Yeah, you're good, Jonathan. He just answered before you, it's fine. You can't sell negative. Who's eaten a negative cake before? Raise your hand.
A negative cake was like a really bad.
No, like negative as in, not as in bad negative, as in like not existing.
I gave it a negative.
Huh? Yeah. Someone in yesterday, I think it was 4th period, was like, well, what if you threw it up? I'd be like, that's still cake. It's just thrown up cake versus like in your belly cake, I guess. Oh yeah, Jonathan said the same thing. Sorry, I didn't see that. Yeah, so positive cakes, positive slices. That's why we're only in that first quadrant. So where do we shade? Do we shade to the right or shade to the left? Okay, so let's think about this. So we can pick a point. What's the easiest point? 0, 0. Yes, I love 0, 0. If we use 0, 0, will I make $500 if I sell 0 cakes and 0 slices? I will not make $500. So that means I need to shade on the opposite side of the line from 0, 0. So the opposite side of that line would be over here. Because if you think about it, if I pick any of the points in here, like if I sold 8 cakes and 60 slices, 8 whole cakes would be 160. 60 slices would be 180. 160 and 180 would not give me that $500. But if I pick a point over here, 120 slices and 32 cakes, that would give me above that $500. Does that make sense, Jonathan? You said oh. Okay, sweet. And obviously, think about it. I want more money, so I want to shade where the bigger numbers are, right? I want to make more than $500. So what is the difference between the points that are on, I'll use my line, my purple line versus the points that are in the blue area? So if they're on the line, they are worth exactly $500. What do you mean there's nothing on the line? There's lots of points on the line.
Like even.
Yeah, but I counted by 20s and 4s. So if I zoomed in, like if I put this in Desmos and zoomed in, there would be combinations that are exactly 500. Like 10 cakes and 30 slices? 10 cakes and 30 slices, I think would make 500. No. Nope. Did I do that wrong? Math is hard. 100 slices, 10 cakes. Yeah. 100 slices, 10 cakes. Yeah. Which would be about right here-ish on the graph. So it just doesn't, because the scale, it does not look like exactly, but. So then if I'm in the shaded region, how much money am I going to make in the shaded region? More than 500. I don't really care exactly how much. I just know that I'm going to make more than 500. So if I'm on the line, it's going to be exactly that number. If I'm in the shaded area, what about the part that I didn't shade? Less than 500, right? If I picked any point that's not in the shaded area, not on the line, it'd be less than. Or charge, usually like a homemade thing. They don't usually charge tax, I don't think, but you could, I guess. What does the x-intercept represent? So I touched the x-axis. That was when I only did whole cakes, no slices. Okay, so I do want you to do the try it, but only part A and part B, because I do want to still graph together for now. So I'll read it. It says, the freshman class wants to include at least 120 people in performances at a pep rally. Each skit will have 15 people, and each dance routine will have 12 people. So you want to tell me 2 possible combinations that would give you at least 120 people. And then when you make your inequality, make sure that X is skits and Y is dances. So take a second to do that. So give me 2 combinations and then try and write that inequality. 1 million skits and 1 million dance routines.
No, we're going 100 skits and a single dance. No, like every cheerleader. I want to.
Wow, no.
No, like for 1 year they learned just a million, and then the next year they performed straight. Like the whole year. There's an entertainment during lunch.
Does anybody have any 2 reasonable number of dance routines? Yes. 10 dance routines, no skits. That's fine. Okay, let's throw a skit in there. So 10 dance routines, 1 skit. Yes. 15 dance routines. And how many? 5 skits. 7 skits and 2 dances was another one. Again, we could sit here for how long and list the amount? Forever. For the rest of our lives. Sound good? Yeah, no, sorry guys. Love you, but don't want to stay here for the rest of my life. So let's write an inequality. So for skits, how many people per skit? 15. So 15x plus How many people per dance? 12, 12Y. We need that to be greater than or equal to 120. Done. Oh, okay. Thank you. So let's graph. You can go by ones on both X and Y. So that leaves us enough room for this one. So go by your ones. 1, 2, 3, 4, 6, 7, 8, 9, 10. And X is skits and Y is dance. Mm-hmm. So just like the previous one, let's make our two options. So what if we had no skits? How many dances would we need? And I think that was your answer, to get exactly 120. 10. So we would need 10 dances minimum to get our 120 people. What about if we had no dances? Just skits. 8 skits. Good. Skits is such a weird word. 8 skits. Be careful when you say that word. Skits. Because it's very close to not a nice word. Yes, exactly. Thanks, Graham. Appreciate it. So go ahead and draw your line.
Remember we did that when we had a sub and everyone was doing
I missed a lot more on digital, I'm guessing.
I guess so. I'm still out apparently.
Wait, at the end of class, can I go on? I want to go on something, and can you tell me what I'm on?
Sure. I mean, we can play that game all day. So let's use 0, 0. Will I get 120 people if I do 0 skits and 0 dance routines? Sadly, no. So that means I want to shade my line the opposite side, which would be to the right. And again, please don't spend 10 years on the shading. Just shade. It does not need to be perfect.
Because you know what? Scribbling can be perfect. That's why people sell scribbles for like $50. Yeah, you can sell this for $50.
So I have what?
If you've ever been to Kirkland, you
Like the
know-
store?
Yeah. It's so, the paintings look so pointless, but they're so expensive.
Paintings are expensive. So the y-intercept represents only dance routines, no skits.
Do you think we're going to this distance class?
I love that so much.
Okay, so you're gonna do the beat the test, but before you do it, and you're gonna tell me your answer in just a second. Look at the graph on the beat the test. So where is that graph shaded? On the left side. So why is that? Well, let's read what it says. It says Coach DeLeon purchases sports equipment. Basketballs cost $20 each and soccer balls cost $18 each. He has a budget of $150. What's a budget mean? I can't spend over that amount of money. So that's why I'm shaded on the left-hand side, because I can only spend up to that amount of money, okay? So what you're gonna do on A is you're gonna make your equation, or your inequality, excuse me. Make sure X is soccer. Why did I make X soccer?
That's the bottom.
Because that's the x-axis. Look at the graph. It's on the x-axis. And Y is basketball. Okay, and we're still listening before you get started. When you get to part B, it's asking if those two combinations are in the shaded area. So is 3 soccer balls, 5 basketballs part of that shaded area? Ooh, look closer than that. Look closer than that. No, it's not. Okay, so go ahead, write your inequality, and then answer those 5 points, and then let me know so I can come look at it when you're done.